All right, day 19. Not enough minerals. We're playing StarCraft? Your scans show that the lava did indeed form obsidian. The wind has changed direction enough to stop sending lava droplets toward you, so you and the elephants exit the cave. As you do, you notice a collection of geodes around the pond. Perhaps you could use the obsidian to create some geode-cracking robots and break them open. To collect the obsidian from the bottom of the pond, you'll need waterproof obsidian collecting robots. Fortunately, there's an abundant amount of clay nearby that you can use to make them waterproof. In order to harvest the clay, you'll need to special purpose clay collecting robots. So this is going to be just an optimization problem. Okay. To make any type of robot, you'll need ore, which is also plentiful but in the opposite direction from the clay. Collecting ore requires ore collecting robots with big drills. Fortunately, you have exactly one ore collecting robot in your pack that you can use to kickstart the whole operation. How convenient! Each robot can collect one of its resource types per minute. It also takes 1 minute for the robot factory, also conveniently from your pack, to construct any type of robot, although it consumes the necessary resources available when construction begins. The robot factory has many blueprints, your puzzle input, you can choose from, but once you've configured it with a blueprint, you can't change it. You'll need to work out which blueprint is best. The elephants are starting to look hungry, so you shouldn't take too long. You need to figure out which blueprint would maximize the number of open geodes after 24 minutes by figuring out which robots to build and when to build them. Using blueprint 1 in the above example, the largest number of geodes you could open in 24 minutes is 9. One way to achieve that is stuff. However, by using blueprint 2 in the example above, you could do even better. The largest number of geodes you could open in 24 minutes is 12. Determine the quality level of each blueprint by multiplying that blueprint's ID number with the largest number of geodes that can be opened in 24 minutes using that blueprint. In this example, the first blueprint has ID of 1, can open a 9, so its quality level is 9. The second is 2, can open 12, 24. Finally, if you add up the quality levels of all the blueprints in the list, you get 33. Determine the quality level of each blueprint using the largest number of geodes it can produce in 24 minutes. What do you get if you add up the quality level of all the blueprints in your list? Cool, let's get our puzzle input. All right, a little bit too much time to cut down again, so I'm just going to walk through the answers. So the first thing we need is a data class for blueprint, and this is basically going to read in our file. And then for each line in blueprint, we're going to use the same regex that we used a few days ago. Just take numbers out of a string, and so that's going to give us this 1, this 4, so on. And then going to grab that into a list, and then make a new blueprint that we add in. Simple enough. And then basically for each print, we need to figure out what the maximum number of geodes that we can get is. So I made a recursive function to do that. In order to help this recursive function, I also added a state class. And the state class is basically going to take in everything that we care about from this point on. So states, the number of bots we have, and then the number of materials that we have. Unlike other ones where we try to do some sort of max by path, we really only care about the in max number. So I basically just put that as a singleton that we can update as we go along. And then instead of having a transposition table, I basically can just have a visited table at that point. So if we visited, we can just skip out of it and we don't return anything back this way. It's pretty much the same, just slight edge case differences, just makes it a little bit easier to program here. So basically our exit cases, if we're out of time, then update our max geos, otherwise return. And then if we've seen this transposition before, we don't need to look at it again, we can return. And if we haven't seen it, we just add it to our transposition state. Easy enough. And then we start checking to see if we can create some bots. So basically, if we have enough minerals and we have enough time, for example, there's no reason to make a geobot with only 1 turn left because it will not be able to find any geodes. And likewise, there's no reason to make a clay bot if there's less than 4 turns left, because you'd have to make a clay bot and then it would have to mine a clay, and then you'd have to make the geode bot, and then it would have to find a geode. That takes 4 turns, so if you have less than that, why bother? And then for each bot type, basically, we're going to clone the state We're going to decrement the turn, of course. We're going to add our new bot, of course, and then take out any minerals we took to create the bot, and then add any minerals that we get this turn. And then we're just basically going to use that state to recurse into our max blueprint again with the print and the new state. And then we're going to do that for each bot. I specifically put the GeoBot first, the Obsidian bot second, so on, because if you can make a GeoBot, it's almost always better to do that first. And then same thing with like the Obsidian bot. If you can't make a GeoBot, but you can make an Obsidian bot, it's usually better to make the Obsidian bot first. And that way we hit branches where our max value goes up faster, and we can prune out dead branches a lot faster that way. We don't get into as many loops where we care about crappy bots. Unfortunately, we still do that sometimes because the crappy bots take way less material to make, so you wind up frequently hitting them over and over and over before you even look at the Obsidian one, because like you don't have enough material for it yet. So to prevent that, I kind of looked at a couple of the ones that we were using for part 2, and then I made an educated guess about how many bots would be a reasonable maximum, threw in a little bit of padding, and put that in as a check. So if we have too many clay bots already, stop making clay bots, right? And then so we do that for all 4 bot types. And then the last thing we need to do is we need to have a waiting state. So basically it's exactly the same. We make a new copy, we take away the turn, we add the new bots, there are none. We add or take away the resources we used, there are none. And we add the resources that we gathered for each of them, and then just blueprint in. So that's just basically our waiting stage to go through one turn. So once we have that, for each blueprint, we're going to set our max geos to 0. We're going to get our max blueprint for each blueprint and 24 turns, and then we're going to increase our score. And then we're at the end of that, we have to also clear out our visited list. I guess I could go at the front as well, but that's just to make sure that we don't, because the visited states are going to be different for each one, because the blueprints are different. And then that's it for part 1. Part 2 is basically, as expected, just the same thing, but more performance. And we only run through 3 blueprints this time, but instead of 24 turns, we have 32 turns. So that's 32 turns minus 24, that's 8 extra turns, which doesn't sound like a lot, but you have to remember that, you know, each turn can branch into 5 different, sub branches each time, which, you know, if you do 5 to the 8, that's 390,000 times longer. Now, not every branch is going to be hit every time, of course, because a lot of times you don't have the material to make a bot, but still the branching factor is way higher. But the first one ran through quickly enough, and I added those checks in just to not get into bot loops and everything, especially important when you have more turns. And I figured it was probably going to run quickly enough that I didn't want to do any additional refactoring. It's no use to spend 20 minutes fixing your code if it's just going to save you 3 minutes of execution time. So anyway, I ran it as is, and it's actually pretty quick. So this run through took about 15 seconds for part 1, about 41 seconds for part 2. Obviously you prefer it to be faster, but as I said, if you spend more than a minute refactoring it at this point, you lost time. So that's all I did. I will of course have all the updated code in the GitHub, so check that if you want to check anything in more depth. If you have any questions, leave a comment. And other than that, I will see you guys tomorrow.